Hello and welcome to Vox Markets. I am John Human and I'm delighted to be joined today by Graeme Purdy, Chief Executive of Ilika. How are you doing, Graeme?
Very well, thank you. Thanks for the invitation today.
No problem. Thanks for coming on. So you've announced some very significant news for the company this week relating to your Stereax miniature solid-state batteries. Can you talk us through what's happened at a very high level?
Yeah, absolutely. Well, this week was the culmination of quite a lot of preparation work, really, over the last year or so. We completed the construction, installation, and then commissioning of our manufacturing facility for our Stereax miniature cells. And last year we were optimizing the process and qualifying the product that came off the line, testing that to understand the quality of the materials and the actual product itself. And we were able to make our first shipment of product, our Stereax M50s, our single layer cells, to one of our key clients, actually, to Blink Energy in Israel.
And what did Blink Energy do?
Blink Energy is a fascinating company, actually. They specialize in energy harvesting from the blink reflex with the view to powering ocular devices. So, smart contact lenses, things like that. And of course, they need really thin batteries that would be comfortable to wear on the eyelid, actually, in order to store that harvested energy.
No, it's incredible technology. We'll come on to that in a minute. I mean, my understanding is this first shipment could be the first of many. Lots of orders lined up across a range of customers and applications. Can you give us a feel for sort of what's coming down the track on the commercial front?
Yeah, well, we've got a portfolio of sometimes impatiently waiting customers who've been with us on this technology development journey. And they cover some really interesting applications in the medical device sector and also in the industrial Internet of Things sector. So, within the medical device sector, we've got things like smart orthopedics, which is where you put compact sensors into replacement knee and hip joints. And the sensors are actually there so that the physiotherapist, the consultant, can monitor the physiotherapy that the patient undergoes post-operation. So the intensity and frequency of the exercise that the patient does, because actually, in order to get a good outcome from a knee or hip replacement, you need to exercise the joint, and a lot of the outcome is driven by how disciplined the patient is in doing that.
So the melding of technology and healthcare.
There you go. And another example is with neuro-stimulation, which is this huge wave of innovation that's going through the healthcare industry, where people are thinking, are there alternatives to chemical-based pharmaceuticals? And there's this concept of electroceuticals, which is all about the stimulation of the peripheral nervous system, so the nervous system outside of the spinal column and the brain, in order to help address things like pain relief, actually stimulating the pancreas to release insulin for diabetic patients so that they don't have to take injections, and also actually tiny little sensors that can help monitor things like chronic heart disease and blood pressure, so that patients have a much greater chance of survival in the long term.
No, it's fantastic technology. What I wondered was, obviously one of the advantages of your technology is that the batteries are very small. But
Yeah.
What are the other factors that make them so suitable to these kind of medical applications, industrial applications?
Well, they're also intrinsically safe, so that the big thing about solid state is that they don't have a liquid electrolyte in them that is either toxic or could potentially leak into the body. So solid state is, let's say, the nirvana of battery design, so that effectively you've got an inert component that has got a much better safety profile for the patient.
So we talked about the kind of the type of medical applications and industrial applications that you could use this technology for. Can we talk about the sort of the market drivers behind the adoption of these devices? You know, as I mentioned, you know, technology and healthcare are sort of colliding head on. Can you give us a feel for the sort of market opportunity you're addressing here?
Well, the market opportunity is an absolutely massive one. Unfortunately, you know, particularly in the developed world, we've got a society that is gradually aging and is, you know, in that old age, having to deal with a variety of chronic and endemic illnesses. And by coming up with these miniature solutions, you're effectively enhancing the quality of life for very large patient groups. You know, there are hundreds of millions of patients suffering from diabetes that could benefit from a neurostimulator connected to the vagus nerve, which would be able to stimulate the pancreas in order to release insulin. And there are, of course, many millions of patients that get joint replacements, knee and hip replacements every year. So the addressable markets are very exciting for us. Actually, just one of these applications in our portfolio of actually 18 engagements that we have at the moment would be enough to give our shareholders a very attractive return on investment.
I think I found a stat that suggested the global implantable medical device market was going to be worth $143 billion by 2028. So yeah, absolutely vast. Perhaps can you talk about the Internet of Things side of things? Because that's potentially even bigger.
Yeah, I think the key thing actually for the industrial Internet of Things is that in order for the Stereax batteries to be applicable, you need to identify hostile environments which can't be addressed using traditional lithium-ion batteries. Because the big thing about solid-state lithium-ion is that actually they are more resilient, in particular to higher temperatures. If you can use, though, a mass-produced coin cell as a replacement, you would always do that, because actually at the moment they're cheaper to manufacture. You know, we're manufacturing at a relatively small scale here in the UK at the moment. Obviously, the deal that we've got with Cirtec in the US in order to scale up manufacturing volumes will allow over time the price points to drop. But right at the moment, in terms of market entry, we're looking for relatively high margin, less price sensitive applications. And so when you think about the Internet of Things, it is, of course, vast, right? I mean, ultimately, there are projections for trillions of sensors, but it's not every one of those sensors that's a great fit for what we're doing with Stereax. We have to identify those ones in hostile environments. So some good examples could be, for instance, at the side of a railway track where you get high temperatures actually from the direct sunlight. You put one of these batteries together with a little energy harvester, and you can power a strain sensor. Same is true for strain sensors that you might put on bridges, gantries, and also wind turbine blades. So these are some of the case studies that we've been working on over the past few years.
Yeah, again, a massive opportunity. You mentioned scaling up manufacturing. Obviously, you're working on a deal with Cirtec Medical, and I guess there's some commerciality around that you can't really talk about. But I guess what's the sort of fundamental concept beyond scaling up of this? I mean, you talk about being able to focus more more specifically on developing intellectual property, and presumably this sort of leaves you with a sort of technology licensing approach in future.
Exactly, and that's one of the things perhaps that we emphasize when we talk to investors in Ilika. We have a capital light business model. We don't intend to build a string of manufacturing facilities across the globe, because we believe actually that we are best at developing technology and then transferring it once it's been demonstrated at a production intent scale. So that's what we've done actually with the Stereax facility we have in Southampton. It is a facility that has equipment in that you might find in very large facilities. The equipment is industrially scaled. and production intent, but we intend to work with manufacturing partners who, have that manufacturing operational excellence in their DNA. And it's actually quite a different culture and mindset to the technology development organization that we are. So, when you also look at other parts of our business, for instance, we have our large format Goliath batteries. We won't build a gigafactory. We will work with operators of gigafactories that want to take that technology and implement it and produce batteries for automotive OEMs.
Yeah, makes a lot of sense. I'm glad you mentioned Goliath, because that was my what I was going to leave you as my final question with. What's going on that front? So we go from the very small to somewhat larger, and I understand you've had some recent success there, securing some funding to take that project forward.
Yeah, Goliath is a really exciting technology. Actually, some of the drivers that are important to the medical device industry are also true for the automotive sector, where they're interested in compact devices that are intrinsically safe. Clearly, if you've got a smaller battery pack, you can design a vehicle around that battery pack that actually looks more compact and more like the vehicles that we're used to seeing built around internal combustion engines. But also similarly, you can say, well, what, I've got the space in my EV. I can put actually a battery pack in, which will give me a longer range, because that's the other design choice that you've got, and that overcomes some of the range anxiety, which may be a principal reason why people haven't adopted EVs already. So you can address that range anxiety factor. The status of that is that we're at prototyping level. We have a separate development facility also in the Southampton area, where we're developing Goliath, and that's been the basis for us securing an exciting collaboration that we announced at the end of January, which is an £8 million program supported by the Faraday Battery Challenge. Actually, 2.8 million of that 8 million is funding for our Goliath program, and we're working on that together with steering group partners BMW and Williams Advanced Engineering, or WAE, as well as Nexion, which is supplying us with silicon anode material. Some of the UK's leading universities, and also a company called HSSMI, which is a consultancy that's going to help us develop more detailed information around some of the recycling benefits of our Goliath solid-state batteries. Because, as we go forward, we've got more and more EVs on the road. Eventually, we're going to start recycling some of those battery packs. And so you want to design in recyclability to your cell design to make it easy to reclaim some of those metals and put them back into the supply chain.
No, it's a fantastic progress you're making in really addressing some of the world's most pressing problems. So yeah, great to speak to you, Graeme, and thank you so much for joining us.
Thanks for your time today.
Thank you.